On behalf of the entire team, I would like to warmly welcome you to this presentation of the publication entitled Product Generation Module, Automated Production Planning for Optimized Workload and Increased Efficiency in Matrix Production Systems within the CIRPe2020 Global Web Conference. The CIRPe2020 is about the topic of flexible mass customization, and Matrix Production Systems serves as one manifestation of flexible mass customization ready production system. There are quite a few reasons for Matrix Production System to gain attraction within the last periods of time. First of all, there is a trend towards mass customization in the sense of many customers require individualization and require high quality at low prices. This poses several requirements on regular production system and often comes hand in hand with shortening product life cycles. Additionally, external regulations, in particular in respect to protecting the environment, can have major effects and push companies towards matrix production systems as a manifestation of flexible mass customization. Matrix production systems are both adaptable and flexible, as they allow products and the combination of products to change within the lifetime of the production system. However, they require a very high investment cost and are expensive to operate and install. Thus, our proposed product generation module increases the efficiency and enables companies to overcome the expensive integration of matrix production systems by boosting their turnover afterwards. Let's look at matrix production systems and how they are constituted. First of all, matrix production systems are made of matrix-shaped layout. For instance, the figure below, which is a 4x2 matrix layout with redundant work cells. Partially redundant in the sense of each work cells has the ability to perform different value editing activities, which we dub as processes in this case, within work cells. And some of them might be similar, some of them might be equal. However, the important part within the matrix production systems is the ability of more than one work cell to perform a given process. Furthermore, the ability and flexibility of matrix production systems come from the decoupling material flow. This is done and realized by the implementation of AGVs, which autonomously guide the transport and material transport within the system. This is the reason for matrix production systems being very flexible. Thus, whenever a machine encounters any failures or further troubles, one singular machine does not affect the output of the entire system heavily, and the rest of the system can still work as prepared, and thus it allows the production system to deal with a much larger flexibility and much larger demands changes. The objective in introducing matrix production systems is ensuring the ability to scale very easily, in the sense of instead of having a 4.2 matrix, we could easily switch towards a 4.3 matrix by introducing just another row of machines and work cells. Also, having a focus on the different processes and value-adding activities allows us to have a kind of universal production system, as it is able to produce different variants and can be very easily refitted to allow the production of new variants whenever many of the predominantly processes can be reused. Last but not least, and most importantly, matrix production systems are a strategical choice and focus on the customer-oriented flexibility, as each product within the system is running in a one-piece flow throughout the entire production steps. However, such a matrix production system cannot be fully utilized, even when regarding a perfectly and maintenance-free system. Depending on the number of work cells and concrete work packages, the figures will vary. However, we can, for instance, look at the figure shown on this slide, where we can associate many different tasks with the different work centers in the system. And nevertheless, there will be some gaps within the production system, within certain work cells that can be used for the production of minor products, for the co-production of not the products which we are looking at right now. Hence, the optimization potential in matrix production system is there, in particular as we are able to use them, since we have a decoupled material flow, which could not be implemented with a regular line production system. So the proposed product generation module optimizes the workload in matrix production systems by enabling the co-production of portfolio external or of minor products which do not deteriorate the quantity and quality of the main products to be produced by the production system. And since matrix production systems implement customer-oriented flexibility, we can easily assume a fluctuating demand, and the ability to produce minor products additionally allows us to have high production system usage even in times of lower demand. Let's have a look at the proposed structure. First of all, it is required to have a look at the free capacities that could be used within the system. That typically entails looking at the free capacities in transport, free capacities in different processes within the system, but also free capacities that could allow replanning of the entire system. Having the free capacities and the ability to allocate different possible products that could be produced to the available free capacities allows us within the third stage to develop different and alternative solutions for the integration and combination for major and minor products. Each of these alternative solutions has to be checked for plausibility, and the profitability analysis has to be determined in order to find the most profitable solution. In our case, we do the profitability analysis and plausibility check with the help of a digital twin, or if we would rather prefer a simpler tool, with the help of simulations. Last but not least, and one of the most challenging tasks, is the control of co-production. That means order release and order routing within the matrix production system is of much higher complexity when minor products are released as well as the major products. Nevertheless, and this is an important part to consider, the basis for this product generation module is an already optimized matrix production system that is already in place. Because whenever you start to plan and implement your matrix production system, you would rather start with optimizing it given the current system boundaries and given the current flexibility and customer demand. Nevertheless, there are quite a few threats to the implementation of such a product generation module, which typically includes a focus of the shift towards integration, and shifting the focus towards the integration of minor products could, without appropriate countermeasures, negatively affect the quality and quantity of the major products. Thus, it is quite important to regard both of them. Let's look at the short case study. In the top part of the slide, you will find the matrix production system at hand. That is either 4.2 or 4.3 matrix production system with given process times for major and minor products. Keep in mind that major products refer to the products the system was built for, and minor products refer to the products identified with the product generation module and which are placed additionally within the system. Given our system and given a different change and layout of the system as well as different product times, we have identified that within a case study, the integration of the product generation module allows the output of main products to remain constant, but also includes the output of minor products. For instance, in a general configuration case, we're able to almost without any loss of time and quality for the main products, to produce minor products in high quantities and thus increase the workload of work cells tremendously. Depending on the situation, you're required to do such a case study and implement the most suitable solution. Most importantly, within the small case study is that even though changing the number of work cells, changing the layout, changing the number of AGVs, process times, types of main products, and so forth, the product generation module is still applicable and allows us to produce minor products. All in all, there are quite a few advantages of implementing such a product generation module, as it can be implemented even with varying number of work cells and layout. It can be implemented with a varying number of AGVs and a varying speed of the AGVs and distribution within the system, but also with the average process time of the main products. This, however, requires, in the first phase, a very detailed identification of free capacities, as that would restrict the selection of potential minor products. And in some cases, due to a better balancing of the AGVs, which allows us to facilitate the product generation and increase the speed of product generation with the help of minor products. Nevertheless, that will be not the case for usual production systems. All in all, there are quite a few interesting results we have gained from implementing such a product generation module. First of all, that the ability to use the co-production principle is given for matrix production systems, even across varying parameters, and allows the production system to effectively boost the turnover and decrease the disadvantages that come with the high investment cost for matrix production systems. Furthermore, having a product generation module allows the production system to increase even higher flexibility and to countermeasure the problems of flexible mass customization in traditional production systems. There are quite a few topics to be researched in following up studies, which first of all should focus on the application of the product generation module and the principle of co-production to different production system and potential production networks, but also the problems that come hand in hand with the production of minor products or even portfolio external products that could relate to supplier substitution, that could relate to substituting your customers, and so forth. Last but not least, one of the main topics should focus on the order release control policies, since the integration of many different products, including the minor products, highly increases the complexity of production control and allows the integration of more intelligent production control policies. At this point, I would like to thank you for listening to the presentation and looking forward to your questions and comments.